Hello my dear students, this is Akash SD and welcome to the ASD physics classes. I hope so. You all are doing really great. So students, in this class we are going to learn about the questions of electric flux and the applications of the Gauss law. Okay, so let's start the video. So students, the NEET 2023 question is that, let's see through. According to Gauss law of electrostatics, electric flux through a closed surface depends on. Very basic question is there. We'll just write here the Gauss law expression. Closed integration E.ds is equal to charge enclosed by epsilon naught. And here if I draw here one Gaussian surface, here some charge is there. Let's take Q1, Q2, minus Q3, and outside let's take Q4 and minus Q5. So remember that one thing, this charge enclosed means which charge? The charge that is present inside this Gaussian surface. So charge enclosed means which one? Q1 plus Q2 minus Q3. After that, what is this electric field? This electric field is due to all the charges, whether Q1, Q2, minus Q3, Q4 or minus Q5. Okay, so basic is clear. Now let's see here. Area of the surface. Remember that one thing, in my previous videos also we have covered this. Electric flux does not depend upon the shape and size of the surface. So whether if I talk about here one sphere, whether it is the radius A, radius 2A, charge enclosed will be how much? If Q, then flux through the surface will be Q by epsilon naught. Okay, remember that, independent of the shape and size of the surface. So let's see here, please here. Area of the surface, no, it does not depend upon the area of the surface. Charge enclosed by the surface, yes, we can see here the charge enclosed by the surface. Shape of the surface, no, it does not depend upon the shape of the surface also. Volume enclosed by the surface, no, volume also it does not depend here. Okay, so very basic. Next students, let's see please here. C1 and C2 are the two hollow concentric cubes enclosing charges 2q and 3q respectively, as shown in diagram. The ratio of electric flux passing through C1 and C2, how much? Okay students, so this is the JEE question is there. Let's take for example this inner cube is C1 and outer cube how much there? This outer cube is C2. Okay, so if I talk about here flux through the smaller cube, flux through which surface? Flux through the smaller cube. So this smaller cube, that means white color is enclosing how much charge? 2q charge. That means we can write here 2q by epsilon naught. Okay. After that, if I write here flux through the larger cube. Okay. Larger cube, how much here? You can see inside the larger cube, yellow color cube, how much charge is there? 3q is there and 2q also there. That means how much? 5q by epsilon naught. After that, if I write here the ratio, they are asking the ratio here, is it? So 5c1 because this is due to c1 by 5c2 because this is due to c2. So what this will become here? Q by epsilon naught will cancel out. So what this will come here? 2 by 5. That means which option is correct? The correct answer is here. Option A is the answer. See how much easy question if we know the basics. Next students, let's see please. Again, JEE question is there. Two charges of 5q and minus 2q are situated at the points 3a, 0 and minus 5a, 0 respectively. The electric flux through a sphere of radius 4a having center at the origin, how much? Okay, very basic question is there. So see here please here. This is the origin, how much? 0, 0. After that, radius how much given? The radius is 4a. That means this side we can tell 4a, 0 and this side what we can tell? Minus 4a, 0. Okay, so radius of this will be how much here? The radius will be 4a. After that, where are the charges? Charges at 3a, 0. Where will be the 3a? 3 will be definitely somewhere here. Now this is 3a, 0, not 3a. This point, let's take, I have written here, this point is P. Okay, so my point P is here, 3a, 0. And how much charge is present? 5q charge is present. At this point, how much charge is there? At this point, 5q charge is there. Now let me write here. At this point, 5q charge is there. At point P, how much charge? 5q charge. After that, you can see minus 5a, 0 is carrying how much charge? Minus 2q. So minus 5a, 0 is here. Let's take somewhere here, point Q. And here how much charge is there? Charge is minus 2q here. Charge minus 2q. This I am telling you. Minus 2q charge is there. Just for the coincidence, this q and minus 2q are matching here. If you wish, you can write here point S also, no problem here. Okay. At point S, minus 2q charge, and at point P, 5q charge is there now. So you see here, you know, according to Gaussian law, according to Gauss surface, which charge is needed? Charge enclosed is needed. Okay. So if we calculate the charge enclosed here, how much? 5q. That means flux closed integration E.ds, or we can tell the flux is given by charge enclosed. How much charge is inside this? 5q. So answer will come here 5q by epsilon naught. 5q is inside and minus 2q is the outside. So correct answer is here what is? The correct answer is here option B is the answer. Okay. Next students, let's say please, very easy. A charge q microcoulomb is placed at the center of a cube. The flux coming out from any one of its faces will be how much here? Okay. So let me draw here one cube here. No? Here one cube is there. Okay. And after that, what is there? The charge is present here at the center. At the center. Let's take for example, if this side is A, this side is A, then this height will be how much? A by 2. Okay. Remember that. Now they are asking the flux through one of the surfaces here. Okay. So you know very well, very basic thing is there. We have learned before also. We know this cube is made up of how many surfaces? 6 surfaces. Okay. So 6 surfaces will carry how much flux here? Charge enclosed by epsilon naught. That means we can tell q into 10 to the power minus 6 by epsilon naught. In the question they are asking through what? Any one of its faces. So that means hence from one surface, what will happen that here? We have to just divide 1 by 6. So 1 by 6 q into 10 to the power minus 6 by epsilon naught. That means which option is looking correct here? See here the power. Here minus 6, here minus 3. That means correct answer is here. Option C is the answer. Is it? Very easy, very easy, very easy. Next one, see please. A charge q is placed at one corner of a cube as shown in figure. The flux of electrostatic field E through the shaded area how much? Here students have to be very careful. See here please. Here the charge is placed at one of the corner. Here is the charge. Okay. So if we will take the symmetry, symmetry means charge we have to take at the center. Is it? So this side one cube, this side one cube, back side in the same way we have to keep how many cubes? 2 cubes, and back side also how many cubes? 4 cubes. That means total how many cubes will be there? 8 cubes will be there. Okay. So if we see the symmetrical 8 cubes, then only the charge will come at the center. So you know very well, through the 8 cubes, how much charge will come? Q by epsilon naught. So from the 1 cube, how much charge will come? 1 cube. How much flux? So Q by 8 epsilon naught. But here in this question they are talking about this surface. Is it? So you will see very well here, charge is here. So in this situation, what will happen that here? In this situation, if we talk about here this surface, okay, and if we talk about here that this surface, and backside, just backside one surface. Here what will happen? Electric field lines will be parallel to the surface. Backside I am talking about here, the backside surface. Okay. Here what will happen? Electric field will be parallel to these surfaces. That means this field lines will not cut the surface. That means here flux will be how much? 0. So due to 3 surface, flux will be 0, and due to rest of the 3 surfaces only flux will be there. Okay. So here I am telling you 1 cube. 1 cube is made up of how many surfaces? 6 surfaces. So I can write here 3 plus 3. Due to 3 surface there is no flux, and due to 3 surface flux is there. Okay. So 1 cube means how many surfaces? 3 surface. So due to 3 surface, how much flux is coming? Q by 8 epsilon naught. That means due to 1 surface, unity rule, Q by 24 epsilon naught. So you can see very well, if you will observe this here, in the question they have given this one and this one here. So here you can see this is half of one surface, this is also half of one surface. That means half plus half, this is making how much? 1 full surface. That means in a very easy way we can tell the flux will be how much? The flux will be Q by 24 epsilon naught. Very basic they are using here. Answer will be what? Answer will be option D is the answer. JEE question. That's why the JEE question is the, sometimes they consider our intelligence, whether we are that much intelligent or not, can we think or not. Next please. If close integration E.ds equal to 0 over a surface, then. So this kind of situation happens in 2 situations. Close integration E dot is 0 happens in 2 situations. Remember that please. The first situation is that when the charge enclosed is 0, then only this will happen. Second situation is that, let's take for example, if we have one closed surface. And what will happen? The number of field lines entering into the surface and number of field lines leaving into the surface is same. And this happens most of the time in which kind of situation? Uniform electric field. So remember that here, if this kind of situation is there, 2 cases. First one, charge enclosed is 0, or the closed Gaussian surface is present where? In uniform electric field. That means the number of field lines entering into the surface, 2, and number of field lines leaving the surface is how much? 2. So this flux will be negative, this flux will be positive, both will be equal, and it will cancel out. Okay. So if you will see the options here, A will not be correct, B will not be correct, C will not be correct. You see it very well. And option D, as I told you, the number of flux lines entering the surface, it will be negative, must be equal to the number of flux lines leaving it, it will be positive. So negative, positive both will cancel out and the flux will be how much? 0. Okay. Next one, see please, important for NEET, important for NEET. See here please, a hemispherical surface of radius r is kept in a uniform electric field. Again I'm telling, see please, uniform electric field as shown in diagram. The flux through the curved surface, how much is there? Okay students, so see here please, here what is there? One hemisphere is there, and here two kinds of surfaces is there. One is which one? This is the flat surface. This is the flat surface, and one more is there. Let's take, I'm drawing here with blue color. This is the V surface, this is the curved surface here. So what I have told you, whenever the closed surface is there in a uniform electric field, what will happen? The total flux will be always 0, uniform electric field. This total flux is made up of how many fluxes? So here we can tell one is the phi curved surface and one is the phi flat. This one, green color is the flat, blue color is the curved, equal to how much? 0. In the question they are asking flux through the V surface, they are asking through the curved surface. So it is given here minus phi f. That is very easy. That is very easy. So see here please, here minus. Flat surface means, let's see here please, again this is the surface is there. Okay, this is the surface, flat surface. So here what will happen, that closed surface is there. That means what will happen? Area vector is downward here. This is my area vector ds. And electric field in which direction? Electric field is upward direction here. They are making how much angle? The angle is 180 degree. That means we have to use the formula. What? EA cos 180. Cos 180 value how much? Minus 1. So this minus and cos 180 will cancel out and it will come how much here? E into A. Electric field is E only, area. Radius is R. That means here area how much? Pi r square. That means which option is correct here? The flux through the curved surface, it will be how much here? Pi r square E. Again I am telling, due to the flat surface, minus pi r square E. Due to the curved surface, outgoing flux plus pi r square E. Resultant total how much? 0, 0, 0. Okay. Next one please students, very basic. If a conducting sphere of radius r is charged, then electric field at a distance smaller outside from the center of sphere would be V is the potential is there, and they are asking what? In the question they are asking the electric field here. Okay, so let me draw here please. This is the charge is there, the charged one is there. Okay, charged. By default we will take which charge? Positive charge is there. Okay, radius how much? R, and this is my center. And here what is there? We have to write here the outside. My observation point P is where? Outside is there, because they told small r is greater than r. So you know very well at point P, no, at point P, electric field how much? Remember that please here, 1 by 4 pi epsilon naught. That means K into charge. Let's take here charge Q is there. So KQ by small r square here. Okay. After that, again, what is V please? V is the potential on the surface of the sphere. That means potential is given here, K into Q by R, somewhere here on the surface here, somewhere on the surface. Okay. So what we'll do here from this, if I write here the capital Q will come what here? V into R by K. Correct? Now this value of capital Q we will put here. Where? Here. Is it? So here we can tell in the question they are asking electric field. So see please here. E equal to K into R square, and the Q value how much here? See please. VR by K. So what will happen? This K and this K cancel. That means here this is coming what here? V into R by R square. Check the option please here. V into R by R square. V into capital R by small r square. So here correct answer here what is? The correct answer here option C is the answer. Okay. Very easy. And the last question is there. See please the last question. JEE 2024. A particle of charge minus Q and mass M moves in a circle of radius R around an infinite line charge of linear charge density lambda. Then time period will be how much here? Okay. So students here what is there? This infinite wire is there. Infinite wire is there, na? Uniformly charged. Okay. And it is having linear charge density how much? Lambda. And now what is happening that here one particle is there. Which particle is there? Again I am telling charge minus Q is there. Na? It is revolving in a circular path like this. Revolving in a circular path. So remember that here one thing here, charge is what here? The charge is minus Q. Charge is minus Q. So here what will happen that here, this is the electric field. Electric field in which direction? Electric field in this direction. So you know very well, the negative charge always experiences force in the opposite direction of the electric field. So what will happen that here? Here the force will be this much here. Okay, and the radius how much here? The radius is R. Okay, so you know very well, as the charged particle is moving in a circular path. That means resultant force or centripetal force will be provided by this resultant force here. Okay, so what is the centripetal force formula, students? Here we know very well centripetal force formula as F equal to m into v square by r. R is the radius, v is the speed. V is the speed. We can write here v is the speed. Okay, now what is the force? Force means charge into electric field is equal to mv square by r. Okay, only magnitude, because direction is very clear. This is acting as a centripetal force. Now this F is acting as a what? Centripetal force is there. Okay, so here what will happen, that students, here we have to find out what time period here. Remember that one thing, here we will do one thing, we'll write in terms of the omega, then only the time period calculation will be easy. Okay, so mv square by r we have written, but you know v equal to r omega, so we can write here m r into omega square. Okay, now q, electric field is given by 2k lambda by r is equal to mr omega square. Okay, 2k, what is k value? 1 by 4 pi epsilon naught. Okay, now after that, if I talk about here the omega square will become what here? Just see please, 2k lambda into q, 2k lambda into q by mr square. Okay, so if I what I do, if I remove this r square, then what will happen that here square root will come here, is it? Now hence the time period formula, time period is given here what? 2 pi by omega. Okay, 2 pi by omega, and here what will happen, that this r square is there now, so we can write here 1 by r, and here 2k lambda into q by m. Okay, so let's put the value of omega here. So what this will come here? No, the moment you will put here 1 by r, so r will go up, so 2 pi into r, and this will become reverse, m by 2k lambda into k. Okay, so just check the option here. Which option is coming here? The correct answer is coming here. Option B is the